Okay, we have here on the board a pretty interesting looking integral. I have the integral from 0 to pi over 4 of the square root of 1 minus sine 2x dx. Okay, now to start with, I thought maybe a substitution could work, but I didn't actually try that. What I was thinking is maybe we can do something with 1 minus sine of 2x. If we could turn this into a perfect square, we might be able to get this to simplify. And what I want to do is, I think for this 1, if I can rewrite my 1 as sine squared x plus cosine squared x, I think that's going to help us turn this into a perfect square. So let's actually just look at that algebra when I do that. So we'll have sine squared x plus cosine squared x, and then I'm going to take my sine 2x and use the double angle formula on this. I'm going to write this as minus 2 sine x cos x. And then we could factor this as a perfect square two different ways. We could do it as sine x minus cos x squared, or I could write this as cosine x minus sine x squared. Just noticing that all three of these are equivalent. Because both these are squared, if we multiply by a minus, the sign's not going to matter. And I think what I'm going to choose to use is I'm going to use this one here. And the reason for that is the bounds. Because we're between 0 and pi over 4. In that region from 0 to pi over 4, cosine is always greater than sine. And so then if we do it this way, we'll know that this is going to be, what's inside the square here is going to always be positive. And then we don't have to worry about absolute values or any of that stuff. Okay, so now after rewriting it, you'll see that we have our perfect square inside the square root. So these are going to essentially cancel. Again, we don't have to worry about the absolute value because this is always positive. So I can just rewrite this now, and we're just integrating cosine x minus sine x. And we'll just go ahead and integrate. So if I integrate cosine x, I'm going to get sine x. And then when I integrate minus sine x, I'm going to get just positive cosine x. And now we just need to evaluate this from 0 to pi over 4. When I plug in pi over 4 here, we get the same value for each of these. It's going to be square root of 2 over 2. And then plugging in 0, I'm going to have, for sine, I'm going to have a 0. When I plug a 0 in for cosine, I'm just going to have a plus 1 here. Then we have 2 of these times square root of 2 over 2, so that's going to give me a square root of 2. And then here, I'm going to just multiply that minus 1. So for our final solution, we just have square root of 2 minus 1. Okay, quick problem there. We'll stop it there. Thanks everyone for watching. Have a great day.